I saw a lot of smiles over here and a lot of smiles over here, so that means that we had a full time and a bunch of good emotions. And now I would like to say hello everyone. Hello everyone who is sitting in front of me, hello who is sitting the right side next to me, and hello everyone who is watching our online broadcast. Welcome to the final of the Hackathon Built Environment Digital Twin, and I would like to ask you one more round of applause. So in case some of you might not aware what is digital twins, but I believe that majority of you know this term, I would like to explain. Or maybe somebody who is accidentally turned on the Facebook feed and saw this broadcast, I would like to introduce what is digital twin. Digital twin focuses on the digital copies of the infrastructure and building which surround us daily. Exactly 1 month ago, 14 teams or more than 70 people started to develop ideas on the topic of digital twins. So 1 month ago, you remember during the whole weekend, all these smart people who is sitting in front of me were looking for new solutions, how to adapt, optimize, or analyze the information that the building's digital twins can provide us, such as safety metrics, real-time data, indoor environment conditions, and etc. During this month, from the 1st of November, these teams were developing their ideas with the help of mentors and experts, and today we will see what kind of progress they have made. And the best evaluated teams, I received the information that we will evaluate 3 best teams, will be awarded with money prizes. So yeah, we have a quite nice money fund. It's 2,500 euros. Applause for that. And but first thing first, so not by the accident, the majority of participants of this hackathon are from Faculty of Civil Engineering and Architecture of KTU. The reason is that the faculty was one of the main organizers of this hackathon, and they, together with Bentley, the main sponsors of the event, initiated this idea to start this kind of event. And with the help of KTU Startup Space, together in kind collaboration, they developed such kind product, if I can say so, talking in the startup terms, the Hackathon of DigiTwins. And of course, now I would like to invite our hosters, our organizers, to say welcome words for you. And for the welcome words, I would like to invite Dean of the Faculty of Civil Engineering and Architecture, Andrius Jurelionis.
Spoilers. All right. Hello, everyone. It's a pleasure to open the second stage of the hackathon. And I would like to say welcome back. When we said, okay, this will be a 2-stage hackathon, we were wondering how many of you will be here today at the second stage. We lost a couple of teams, but for all of you who are here, I'd like to say congrats. You survived this month, and you developed something. We are really excited to see what you have developed. And during this month, you've been working on these challenges and on your projects. Me and Darius, the head of CSCI, we went to Bentley event, Year in Infrastructure, where our university was nominated for the category of on the digital campuses and cities. We were one of the nominees to receive the Bentley Systems Award. We got not the first place, but still we got a lot of visibility there. We were mentioned as a university in Bentley Systems keynote speech, and we received the Founders Honors Award for everything that we do in the university, and you are part of that. So we're really happy about that. What's next for us? Just so you know, we are still continuing to develop our smart city, smart campus, and we see digital twins as part of this digital campus and smart campus ecosystem. The building that is newly constructed, MLab, is undergoing all the process of creating the digital twin. And also, just almost like 1 week ago, we launched a Horizon Europe project in the faculty, which is has a budget of around 1.5 million euros. And the title of this project is Boosting Research for Smart and Carbon Neutral Built Environment with Digital Twins. So as you can see, the university is moving towards this direction, so you will be exposed to more things digital. And I just wanted to say that, you know, this first hackathon that we did, we were always wondering if this will be a success, what will be the result of this. At this point, seeing you here, I would say that you definitely should expect the same hackathon next year, and we will have DigiTwin 2. Maybe better organized, hopefully, maybe with more visibility, maybe even with more teams. So yeah, welcome everyone back. We are looking forward to hear your presentations. The evaluation committee is ready to evaluate your work. And yeah, the best of luck to you. Thanks.
Thank you, Andres. I can see that a lot of activities are upcoming next year, and now you can see in the slide Greg Demchak. And I will turn on his presentation. I just want to check, should I share his screen as well? Technical guys, please. Should I share the screen of the presentation which will be delivered in Zoom?
It'd be great if I could share screen.
Yeah, you will be, but I'm just wondering if I should share the screen. By the way, Greg, if you would see the audience, it's a full of people.
Ah, that'd be great to see.
Okay. Just 1 second, I should share your screen as well. So just be patient, but if I would share, he will not be able to share.
I think if you share Zoom, I'll just share my screen.
Just 1 second. I will give the role of this.
And at one point, you can also turn us around so that we see the audience. Just to turn the laptop around so that we can see the audience.
Željko, it's quite complicated to do that because today we have 3 cameras. Our yeah.
Okay, I'm sharing my screen to your screen. You should see my screen on your screen.
Okay, small technical issues. I will present shortly our next speaker. So it is said, if you want to inspire others, you have to be inspired. And in this case, you are very successful because today, before the pitching session, we will have an inspiring speech delivered by Greg Demchak, who is the Senior Director at Digital Innovation Lab in the UK, and he will deliver the presentation, very interesting one, about how the industry might be transformed through innovation. Please give a round of applause, Greg Demchak. Everything is fine.
Okay, cool. Well, hello everybody. I can't see everybody, but nice to meet you digitally, from a distance here in London. I would love to someday visit your university and see what you guys are doing first.
Greg, sorry to interrupt you. I received the information that is the wrong screen you are sharing with us. Maybe you can share another one, because I received the information that it's the wrong screen of yours.
So I can see it online, Greg.
Everything is fine. Everything is fine now. Please continue your presentation. Thank you.
See my face, okay, so be one slide in my face. Anyway, I'll just jump right into it. So just by way of introduction, I run our innovation lab here at Bentley Systems, and this whole culture, this whole idea of hackathons and testing things out and trying new things out and failing constantly is really part of something I engender in my team. And I'm going to walk through a little bit of my actually career path as maybe a source of inspiration for all you students, because maybe like you, I started out in university um, actually as an architect, but even before I became an architect, a very young age, I was very much into model making and video games. And so this image here is kind of the reference for me. It's actually a model built with Legos of Nintendo, and I even had video game consoles that even predated the Nintendo, just to kind of to date myself. But what I found interesting with Legos, you were able to basically construct digital models of something and sort of simulate a future state before you actually built it. And then video games is also a way to kind of get yourself into like a digital world, like a prototype world. And for me, this idea of model making in video games, in fact, when I sort of was thinking about how I want to talk about to you today, goes way back even before I even had an idea of like where my career was going to go. And ironically enough, it's exactly where I'm at today in my career. Like this whole idea of model making and video games are now merging in a really interesting way. So I just kind of want to set that up to say that whatever your passion might have been or interest, even as a young kid, can find a way to actually carry itself all the way through your career in ways that you maybe never could have possibly imagined. And so for me, actually going through architecture school, undergraduate and graduate school, when I was a graduate at MIT, I got exposed to explicit 3D and parametric modeling. And at this point, I sort of had to make a decision in my career, continue working for an architect. I was employed by an architect in grad school, using 3D modeling and parametric tools for architecture, or pivot and take a bit of a risk and join a startup. And I went the startup route, in fact. And the company I joined at the time was called Revit Technology. It was a small startup out of Boston, and they were hiring domain experts, architects out of school. In this case, right out of MIT. So I was part of a select group of students who just ended up in this startup, and we got to reimagine and reinvent digital architecture tools. And if you're familiar with the product Revit, I had a first row seat and actually hands-on experience in developing that software and bringing a new way of thinking about CAD into the market. That was really cool. And that was all about 3D modeling and designing interactions for 3D modeling. So I was able to kind of carry my love of architecture and 3D modeling and form making right into the actual software experience itself. Um, and sort of once that product stabilized, I was like, well, I was ready to kind of take on the next challenge. And once you kind of get into this, into the sort of that startup mentality, it's hard to let go of it. So I actually left Autodesk and I joined another startup called Synchro Software. In this case, this was adding the element of animation and time and construction sequencing to 3D models. And so this was really cool. It was now going beyond just almost back to the Lego idea. If you ever build Legos, it's a step-by-step instruction manual on how to build something. It's not just here's a bunch of bricks and figure it out. Actually, you follow a series of steps. And so Synchro was a lot like that. It was like, wow, I'm suddenly building software like you'd build Legos, but actually for large scale, massive construction projects all over the world. So it's a way to kind of again carry these ideas forward into software itself. Super amazing. And by evolving that product, then that led actually to the being acquired by Bentley Systems. That's how I came into Bentley Systems, is through our startup being acquired. And now, even within Bentley, it wasn't enough to just keep building Synchro. I've actually brought gameplay back into the system, and I'm going to show you that in a second. What does it mean now to take things like Unreal Game Engine and Unity and Xbox controllers like this, which I'm using on a regular basis, and VR interactive headsets? These are all part of my daily workspace. and bring that into the market. And without going maybe out of Bentley, how can we innovate internal? So just if you haven't, if you're familiar, I don't know if you've seen these tools. This is a shot of Revit. I was the lead designer for a lot of the features in this tool. And the innovation here was actually thinking outside the box. Instead of using layers and everything you're familiar with layers, we actually invented this idea of tools named after the object you're creating. So the wall tool, window tool, door tool, these were all very new concepts. Didn't exist until we came up with that. Everything at this point was abstract layer systems. This is Synchro. Looks a bit familiar. Took a lot of my learnings from Revit and just injected it right into Synchro. The interface is quite similar, but in this case, we introduced a construction timeline, the ability to animate through construction using a construction sequence. And oops, I want to share, these are some examples of actual work as a result of internal sort of hackathons that we did as my team. So on the top left, actually, one of the first examples, we took a HoloLens, a virtual reality, mixed reality headset, and did digitally align the construction models with the physical job site. So this is prototyped and hacked together, you should say, with a client here in London for Crossrail, where the user could actually see construction animation sequencing through a mixed reality headset. Top right was a huge project, Santiago Airport in Chile. I actually visited all these sites, by the way. Cool thing about this job transition when you get into software, instead of maybe just working on one or two pieces of architecture in the city you happen to live in, software allows you to go visit locations all over the world and see how different localities and different environments adopt and use this software. So it's a really exciting project to work on in Chile. Bottom left is also interesting. This is now taking photogrammetry models and from a drone capture and rendering that inside of a mixed reality headset. First time this had ever been done. Again, all hacked together with a small team, by the way. The team that built that, 3 or 4 of us, were able to build that experience and get 3D, like high resolution 3D models running in mixed reality. And the platform we're using for these, all 3 of these, was Unity game engine. And then the bottom right, you see kind of immersive projection systems. What's it like to have game-like play with that? So these are all kind of interesting opportunities to think about if you're already building 3D models. Actually, the potential for these 3D models to be expanded to more and more people and invite more participation, I think is unparalleled today, especially with game engines. And I'll show this one too. This is let's see if this is going to play. It's a video. We actually just produced this about a bit of an internal hackathon, I would say. Sort of the same idea. We built this entire example recently for our Year in Infrastructure Award. And when you think about what is the metaverse, the way I approach it, and I encourage all of you to think about, is just to go try it and just make something and see what you learn from it. So I said, I want to make a metaverse experience for our Year in Infrastructure Awards event here in London that could work on desktop and also in VR. And so rather than just talk about, the metaverse is a virtual world and it's using game engines, we decided to just go ahead and build one. And with a small team, again, not more than 4 or 5 of us, we're able to pull this together in less than a month. And it's all about combining a lot of the parts and pieces that might already exist and just putting together in new ways. So what you see here is running video, running text, pulling content. And then the new thing that we figured out here was how to teleport from one location to another. And even these sort of magical moments of like, teleporting up into like a space station, for example. The cool thing about using these game engines is there's no real limit to your creativity. And obviously you see that if anyone plays any mainstream indie games, you know what I'm talking about. Games allow creativity to just emerge and take flight. But what's cool here, rather than just let's make a fun game. Here you see, this is a real recording right off of real-time gameplay. Now flying through a highly detailed, fully engineered BIM CAD model with an Xbox controller at high frame rate. And so what does that kind of mean for us in our industry? So this is kind of a sort of thought I want to lead you with is like, whatever your passion might be, it may seem childish, in fact. It's like a Legos or building models or that kind of like intrinsic desire to create something. What I've found personally is carrying those with me into my professional life has allowed me to like create incredible experiences like this, which I think this is for me, I think the next level, this is sort of this metaverse, like what's the next kind of level of experience that it's not just fun and games, but actually delivering huge value for the professionals that we all serve or intend to become architects, engineers, builders. And so with that, I just kind of want to end with a quote from Matthew Ball. And I encourage everyone to kind of read this book. It's a quick read. I think he does a great job of talking about the metaverse, this new medium that is emerging. And if I think about 3D, BIM, 4D, and what might be next, I think it's the digital twin. You're right. And the digital twin is going to become a foundation for what we think is the metaverse. And so think about this massively scaled, interoperable network of real-time rendered 3D virtual worlds that can be experienced synchronously and persistently by an effectively unlimited number of people. So I can imagine a time in the not so distant future where all of us will be together reviewing the results of your hackathon in a metaverse together. And I won't just be a little head on a screen. I could be actually meeting all of you together with your avatar, and you could walk me right through your model, and we could have a full-blown discussion about that. And I think that is the future. And I think your generation, right? You're the ones that will be now the next level that will be, the new Mark Zuckerbergs of the world, inventing these new experiences and new ways of interacting with our physical and digital world, our physical and digital selves. So I hope to all see you next time, if not in person, in the metaverse. So thank you so much. I'm really looking forward to seeing what all of you produce at the hackathon.
Thank you, Greg. It was really interesting to listen and to see so many practical examples of yours. And I really like your attitude when you were talking about the gaming part, how to involve the gaming part in all the solutions they are developing in the digital twins topic. And what I like the most about your presentation, that you included this factor of metaverse and said that maybe next time maybe we will not have the camera, but we will meet in the metaverse as our figures will meet there. So thank you, Greg, once again. It was really inspiring speech, and I would say it only inspires not by the contents you provided, but also you were precise on time, and it's a good example of our upcoming pitch session, because students will have 7 minutes to 4 minutes to provide their presentation. So you are a very good example in all the ways. Thank you once again.
Cool. Thank you.
And now let's move to the final and the most exciting part of the event, so the final pitches, and during which we will see what kind of progress you made during this month. And these goals will be evaluated, these presentations will be evaluated by jury. And now I would like to present our jury members who will decide who will split the money prize fund. So the first jury member, I already presented him. It's Dean of Civil Engineering and Architecture, faculty Andrius Jurelonis. And we have several new faces on the board. So the second one is the head of KTU National Innovation and Entrepreneurship Center, Mindaugas Bulata. We have Associate Professor and Vice Dean for Studies at Kaunas University of Technology, Laura Stasiulienė. We have on board President at Lithuanian Construction Association, Dalius Gedvilas. I can see that maybe Dalius is, no. So today we will not have Dalius, but I believe that he is watching broadcast somewhere, with his company maybe. Okay, so we have in place here a general partner of Baltic Sandbox Ventures, Andrius Milinavičius. Head of Center for Smart Cities and Infrastructure at KTU, Darius Pupeikis. And we have two partners who joined us remotely, but you already know them. And I would like to present Sandeep Jadhav, who is co-founder and CEO at CC Tech. Hello, Sandeep. Are you here with us? He is not yet here, but I already heard and saw that we have Željko Djuračius, who is director at Bentley Education, and he delivered presentation in the first stage of the hackathon. Željko, are you with us?
Yes, of course. I'm very excited.
People are providing a round of applause for you, and maybe several words from your side, because you are always very positive and inspiring.
Well, yeah, okay, thank you for your kind words. I'm really anxious to hear about your progress. I remember when I was in Lithuania, when we started the hackathon, and on the first day, most of you saying, well, I have no idea what to do with that. And then 2 days later, having those wonderful presentations of great ideas that you had. So I can only imagine what you could produce after that in this 1 month. So I'm really looking forward to see results.
Okay, thank you for your kind words, and we are eager to see what was developed during this month as well. So, as you know, this month was dedicated to developing your idea. Therefore, during the final pitches, we are willing to see, and you have to demonstrate the progress you made. And during your presentation, small technical details in order we would be on the same page. So during your presentation, you can show if you have a prototype, mock-up, or another practical example of how your idea works. To save time, you already know this information, but I just want to repeat myself once again. Please demonstrate the working prototype in a video format at the end or at the beginning, how it's more convenient for you, of your presentation. And due to technical reasons, it will be not possible to display your prototype through the platform. So 3 minutes will be dedicated for your pitch and 1 minute for the video you prepared. And the jury members also will have 3 minutes to provide questions and answer session. So in general, we will have 7 minutes. So 3 minutes for your talking part, if I can say so, and 1 minute for your video. And as I said in the first stage of our hackathon, the idea must be presented by one team member, and later on the rest of the team might join a question and answer session. And when the time is out, you will see the clock over here on my left side in front of you. You will hear the sound. The sound is not very nice, but just track your time. And that means when you will hear the sound in 10 or 15 seconds, you should wrap up your presentation. If you will not do this, I will just ask you to stop your presentation. But as I remember from the last time, you were doing very great by tracking your time and you were precise. So I don't want to take your time. I would like to go directly to the presentations. One more thing, evaluation criteria. Evaluation criteria didn't change from the last time, but I just want to repeat it, maybe for the jury members, maybe for those who are watching online, what kind of evaluation criteria will be evaluated. So The jury will evaluate teams according the following criteria: the relevance and the need of the solution, the created value and impact, the novelty of the solution, potential of the solution, presentation quality, and completeness on a practical level. Especially this part today is very important for us. So I think I said everything. If you have any questions, comments, you can talk now or will remain silent for. Okay, I'm just joking. So now let's move to the first presentation. And I just want to say one technical thing that I just want to ask the team number 8, are they willing to present? Because they were doubting. Now I can see the raised hands, so keep in mind the team who is responsible for tracking the evaluation process, that the team number 8 will be not delivering their presentations, I believe. Okay, so let's go to the first presentation, and the first presentation will be delivered by the team number 1, and the title of them is Life is Hard.
Hello. Okay. Hello, everyone. Our team is Life is Hard. Finally, it's better since it's the last day of the hackathon. For the past month, our team was developing a prototype of a program that helps firefighters to do their job more effectively. So let's do a quick recap of our idea. Let's do this way. This is not working. Oh. Okay, let's do it faster. So basically we found out that the response time of the emergency services got longer, and you know that the time is the most important factor in an emergency situation, and since every minute saved could mean saved lives. What our team is proposing to save time is to provide emergency services with 2D and 3D mapping, with information about locations of people in the building and information about temperature and CO2 levels in different rooms. Of course, there are some similar products out there that offer people and fire detection, information about temperature and CO2 levels, but what we are offering is a 3D model with live data about the emergency. How our solution works. So fire detectors indicate the fire, and different sensors indicate space where people are. And with the help of the digital twin, a 3D model is created and provides dangerous zones and locations of people, which is presented on user interface with live data. There are some, right now our solution is adapted to the university type buildings, since we had access to that kind of building, one of the key to use establishments. But if we want to do this kind of product in real life, there should be sensors, not cameras, installed in the building to provide detection of people without violating the privacy. And of course, our sensor should be fire resistant. Our product could be adapted not only in universities in case of a fire, but also in situations like crowd crashings, terrorism attacks, and gas leakages. Also, it could be used in simulations, emergency simulations, and that could help to improve evacuation time in case of a real emergency. So let's go to our prototype, which is here, yeah. Now you can see a 3D model of building which is on fire. Obviously, green indicates safe zones, red danger zones. And it looks kind of messy, right? But you can go through different floors and 2D map is presented. The little person represents that there are some people there. Also, you can browse through different rooms. And there you see information about the temperature there, CO2 levels, and if there's any people out there. Of course, it could be further developed. We could provide different information, like what kind of dangerous substances are in the room, for the firemen to know that there needs some kind of different fire extinguishing. Yeah, thank you.
Okay, thank you so much. I believe it's the hardest part to open the floor, so you did it great. And now questions time. Do we have any?
If I may, very easy question. If I were a fireman, what kind of information I would get? Because I guess I have no time to look through 3D map of the building, so how it would work, the interface with the fireman.
So we are thinking about the bigger picture that the fireman could have like an iPad or of some sort, and he could see this 2D map. And like in the red zone, you can see a person, and to know that you have to go there first. Yeah, so basically you see the people. The information, maybe it's not that important like the temperature and levels, but it's just additional information. But the location of people is the most important part of our idea. Yeah.
Or it could be coupled with the glasses and GPS, also location of the fireman. Okay,
It's
I passed the micro.
complicated.
Thank you so much for your presentation. It's not easy to start. So congratulations on this. You can already relax. It is a truly very impactful idea. I really respect your team and what you guys did here. You were mentioning the the GDPR, right? The connecting to the cameras that are usually in the buildings. I believe during the emergency, it's not the case, the GDPR, right? We just need to save lives here.
The last time we did not mention that part, and there was a questions about the privacy. So we went through the idea again and found different solutions.
You mean the mentors, right?
Yeah.
Well, they need to ask something, yeah? So GDPR is a very nice topic to talk about, but when the building is on fire, no one cares about the privacy at that point. Do you have any idea on the business model? How would your service be sold, or how would the math work behind it, right? You're not here as an NGO.
I think it should be like more like a national thing, not businesses would buy it, but like a city, and it should be implemented
B2G?
by the
Business to governments, you mean?
Yes, yes.
Okay. Okay, can you say a couple of words about your team, and do you have enough of skills to actually execute this solution?
Well, all of us are civil engineers, not programmers.
It's a good start, okay.
Yeah. So if we want to develop this, we need some programmers for us to help. Because this was very challenging for us. It seems very easy what we did, but for us it was a headache. But yeah, with the help of programmers, I think we could develop it.
And maybe the last question from my side, sorry, jury members, do you have at least an expectation on how much money would you need to create an already working prototype that could be tested with the firefighters?
I wish I could answer it. But I don't have business background so far. $1 million, yeah.
Okay, thank you for your presentation. Thank you for questions. Okay, now I have two. And now I would like to ask to come to the stage the team number 2, and the team title is Art Lovers. Everything is fine, you're doing great. Maybe I put this here. You can see here and please stay here.
Hello, everyone. So our project is called Self-Tinting Windows, and the system is called Smart Tint. So the main two problems that our system solves is the cost of room ventilation, because for a bigger house, especially for our chosen building, it could build up to a 5-figure sum in human well-being, because a poor quality of air and heat can really affect people's mental state, motor skills, can cause headaches, etc. So our main idea, our business model would be business to business, and data would be marked every 5 minutes. Then we would have sensors which track temperature and transfers data into our system. And then due to our algorithm, windows would tint according to the need. So we would be able to see live data. On your right, you can see our mobile app, which is also called Smart Tint. And you would be able to either choose that Windows Tint automatically or manually. So you would just have to check the right place. And if you choose to regulate it manually, you could choose the floor, the side of the building, you could see the temperature inside, and you could obviously choose what percentage of tint you need. So for example, we chose this side, and you can see that it is, I guess, east, and it's 60% tinted. We would also have sensors inside where all this information would also be available. And you could also choose whether to do everything automatically or manually. And you would have all this information there too. So us versus them. Our system would be quite great because it's blocking UV radiation. It saves a lot of energy. We don't have any blinds. So it's more aesthetically pleasing. We have up to 30 transparency modes. We, as you already seen, created an app. We have an automatic system, but also a manual one if you're interested. And we have temperature sensors. The great part is that there are no additional charges for installation, because our windows are installed just the same as regular ones, and our system would pay off in about 3 to 4 years. So now my colleague will continue.
Okay, so now here we have an MLab prototype for which an algorithm has been developed, and which tracks data from indoor sensors and changes windows automatically due to our algorithm. So here in the left lower zone, we see data collected from the indoor sensors that we had installed, and we see that it is less than 21 degrees. So the transparency is automatically between 80 and 100%. Now we see that the temperature has increased to between 21 and 22 degrees. So the clarity of the windows has also changed, which is in the middle of 40 and 80%. And now, lastly, we see that the temperature has risen up to more than 22 degrees. So the transparency has gotten up, has decreased to 20 to 40%, and the windows are darkened a lot more. And the system automatically tracks what temperature there is and changes the transparency mode. And after some time, we will see that the temperature has again decreased to less than 21 degrees. And so the windows came to have returned to their original state. So that's it.
Okay, thank you for presentation. Now it's time for questions.
Thank you for your presentation. I have a question regarding the risks of your solution. Did you make some kind of analysis? What are the risks?
Risks. No, we haven't, but
we thought about cons of our system, but the only con that we saw was that it's quite expensive for smaller buyers, for individual houses, so that our system would only be for bigger places such as universities or museums, but we didn't see more drawbacks, so not really.
I just want to ask Željko if you have any questions, just raise your voice because we cannot see you yet. So if you have any questions, just say that I want to ask and I will pass the word for you.
Yeah, no worries, no worries.
Okay.
But no, at this point, actually, I had a very, very similar question on for whom is this meant, and did you do a business case on how big the market would be?
yeah, we kind of thought about that. We think that it would be a big, I mean, it would be a big build. It would be for big buildings, and the market would be great, in our opinion, because it has a lot of pluses. So, yeah, compared to others.
Okay, thank you.
It's a very interesting idea, guys. So congratulations on that. But my question is, could you elaborate a bit on the competition, and how did you estimate the 3 to 4 years to pay off? Because it seems like a big investment, and especially for big buildings, it's even more expensive.
Yeah. So we were thinking about a lot of possibilities, like transport, installation, and all the other things that would cost. So
we also, the count was not very precise. It was just around 3 to 4 years, because we counted that we don't need additional charges for installation, we don't need any blinds, we would also save quite a lot of money on ventilation, and when others only had tinting, but it would cost a lot more because they either had membranes installed and they had specialists to do that, whether our windows can be installed just by like regularly. And also, I forgot. Well, just we added some things that we need and don't need, and rounded up the sum, so it could be more precise, but we just didn't have that much resources to count everything very precisely.
Okay, thank you for your presentation and thank you for answers. It was the team Art Lovers. Applause for them. And now we are moving to the strong ones. It's the team number 3, and they are made of cement.
So hello to everyone. Today we'll be presenting automatic natural ventilation. And as you can see, there's a sneak peek on the slide of how it will look like. So the main reason why we decided to create this solution, we saw a big problem in air quality, especially in labs. And as you can see, there are 5 indicators that impact the quality of air. And in laboratories where fresh air is very much important, we decided to create this solution. So compared to other ventilation systems like wall-mounted mini recuperators and mechanical ventilation, ours is the cheapest one. And the biggest advantage of our system is that we can manage everything through the app. So here's our user interface. It has a lot of outdoor parameters like temperature, wind speed, CO2. It has specific rooms, and in each room has indoor parameters like indoor temperature. It has different controls like window, alarm system, lights, and the ability to automate everything or to manage by yourself, being at the house or somewhere else. So we also thought of our development stages and business plan, sort of. So it starts with the installation of mentioned sensors. So we thought it might take about 3 months. Then fitting of our automatic window opener. Then writing a code, putting all the data to it, and creating user interface and having a fully automatic system. We thought about the time when we'll have a finished system, and then that would be about the year 2024, at the second quarter, and it will the development itself will cost 8,000 euros. And in comparison, this is our company's name, Winmock, and in comparison with other companies, our company has way more features. It's way more cheaper, and it's also better. And we created a short video, which helps you to imagine way more easier how our system works. So basically, we wrote a code for a button, which you press one time and all the windows start to open, and you press one more time and they start to close up. And this ventilation system works with both with mechanical ventilation system. So here is the video. So here's the button. And that would be it. Thank you all for your attention.
Thank you for the presentation. And now it's time for questions.
It seems to me that there are plenty of competition in the field. So maybe you could once again elaborate a bit on why are you better? Because there are automatic windows, and also we can always use human manual work. We can just open a window, right?
Yeah, but it's better to automate everything and to not do it by yourself. For example, you're sitting there and you have to open the window. It's way more easier, right?
Walking is good. No, honestly, it's just like I've seen similar solutions in my life, right? I've visited my friends. They do have automatic windows. So why is this solution better? Because if you say it's cheaper, well, from the business perspective, why should you sell cheaper if others earn more?
Because it works with mechanical ventilation system, Can you repeat your question, please?
Just like from the competitive landscape, right, perspective. So how are you better? Maybe you have extra features that others don't
Yeah,
do?
our app, we designed an app, you can use it, and it's way more convenient. You can use it, you know, at your house, somewhere else.
But we can use the thermostats that already installed, and they also have a lot of solutions that would be that can be used as an automatic solution.
Yes, but
Okay, that's something to think about, right? Dear jury.
Just a quick one. Can you imagine what kind of sensors would be useful for your solution? I mean, if you would like to control the windows individually, not you know, automatically, by the use of some sensors, which kind of sensors would you use?
so by individually would be temperature outside and inside, mainly inside, and CO2 emission sensor.
All right, thanks.
Thanks a lot for the presentation. My question is rather practical. Now it's like -6 outside. So can you use this in winter, and how would that affect the class of the building? If you have like A++ and so on, and you use that kind of ventilation, so is it compatible?
We haven't thought of A++ house model, but it's definitely, you can use it in the winter as well, because just for a shorter period of time. So that would be it.
You are on time. Thank you once again for your presentation. It was interesting to see and to hear. And now I would like to present the team number 5, and the team number 5 is called Pitoni. I'm sorry. We announced you a little bit earlier. We will have the team number 4. You have to wait a little bit, just prepare better. We have the team number 4, and the team number 4 is Hackathon.
Hello, I will be representing Team Hackathon, and today I would like to introduce you to our idea as well as the progress that we made this month. So for this, we decided to go for something that is innovative as well as highly relevant. Our problem is thermal inefficiency. It is a term that refers to buildings' inability to retain heat in winter and cool in summer. It often occurs because of bad technological decisions or climate change. So bad heat retention or bad air circulation in a building can cause molding as well as worsen the health of the people within the building. Bad heat retention also causes higher heating bills and is bad for the environment. So European Parliament highly addresses this issue. Their goal is to accelerate the renovation of existing buildings by 2050 and fully financially support the development of the idea of renovating all buildings using advanced and innovative technologies, linking them to economic efficiency. With that in mind, that's where we come in. We are proposing digital twin for building renovation and monitoring. First step of our action plan is to make a digital twin of a building we wish to renovate by scanning and detecting its problems. Then by using digital twin, system suggests most efficient renovation strategies. After the renovation happens, if the renovation was successful and the building is thermally efficient, we can use the same renovation plan for other similar buildings. We monitor and keep track of the building's information for the rest of its life. So program makes the predictions how the building will age, what problems it might be facing in the future. Every year an analysis on this building is made. System detects the problems, the energy inefficiency, analyzes the data, and prepares strategies or suggestions for the future. Changes can be made, so the plan can be changed and to reduce the thermal inefficiency in the other future buildings. So our solution suggests easier, faster, as well as cheaper designing stages. All of the building is constantly managed, which means that new problems can be tackled as soon as they occur, and no long-term problems lead to longer lifespan of the building. Good air circulation improves health of the people. Energy-efficient building is better for the environment. And now I would love to present you our video. So due to lack of resources, as well as lack of knowledge and experience in this field, we weren't able to fully implement our vision with iTwin, but the prototype I will soon show you is the progress that we managed to do. So we see a colorful target that is supposed to act as a heat map on this lovely house. As we click on it, it zooms in and shows us the information about what the situation of thermal bridging in that specific spot is. Do we need a reconstruction, as well as gives us a solution for our problem? However, we weren't able to fulfill our vision with iTwin, so we made a movie of how it will look like if we develop it further. So this is the same table that we saw in the last video. However, this time it gives us an option to generate solutions ourselves. We can choose a solution, a material that we would love to use, as well as a manufacturer if we want to. So dimensions of the material can be chosen as well. The program calculates everything and gives us results. So if we are not happy, we can always generate another solution. Thank you.
Thank you for a very, very nice presentation. And now questions time. Maybe we have the remote question from Željko.
Yeah, I actually do have a question. So you're talking about renovation, which means existing buildings. So how would you collect data from those existing buildings? Let's say building is 50 years old or 100 years old. How would you collect those data?
So we do a scan of the building. So if we want to create a digital twin of the building, we have to scan it. So that's what we do. And we know what kind of layers it has, and we can make predictions then.
All right, thank you.
I'm not convinced. I'm sorry. What are you scanning? And you said like you will continue to monitor the building in the future, right? How are you going to do it? Are you setting up some equipment on the buildings? Just like elaborate a bit more on at least on your vision, how it could work, okay?
Thank you. So we use cool. So we use thermovisors that you can say they see through the walls, and once a year. If the problems are still there, or if the new ones occurred or something.
Yeah, but then you should sue the company.
Ourselves, we should sue ourselves.
Okay, I have a broader question, because when we speak about renovation, it's not only walls and roofs that should be insulated. Did you consider other aspects of renovation strategies?
Say yes.
Okay, like for example, maybe it is not the best solution to make thermal resistance of the partitions better. Maybe it is better to install alternative energy sources, and the energy will be clean, and solar panels and so on, and the efficiency of the building will be better.
So if we add solar panels, but the building is still energy inefficient, so what's the point? We have to make the building energy efficient.
Free energy.
But it goes nowhere.
But
so
it's
what's
free.
the point? Oh, okay. We have free energy and we live in cold building.
About the business plan, okay? Can you elaborate on the business plan, please? How will you earn money?
We have not thought about business plan, actually. Almost at all. I'm sorry.
Okay, thank you for the presentation. It was the team Hack Attack, and now I would like to ask come to the stage the team. I'm glad that it's not non-toxic snakes, pythons.
Hello, everyone. As probably everyone knows, there is a large number of buildings that are getting older by the day. They consume way more energy and aren't as efficient compared to newly built buildings. And the way to fix that is obviously renovation. We try to think different about it, and what if it would be possible to attack and improve only the most problematic parts of the building? Using different types of sensors would help us to achieve that. All the collected data, such as thermal bridges, humidity, and more, would be uploaded to BIM model, from which optimal solutions would be generated, calculated, and suggested to people. So our team separated into two groups. So some of us was working on the Python and others on the Python platform. So firstly, I will present the Python project. So we created energy flow calculator that show us how much energy your wall uses. So you need to put some values in, like the heat transfer coefficient of wall, of windows, outside and inside temperature, and also the areas of windows and walls. After entering these values, you will get the result, your result, optimal result, and also the recommendation, is renovation is needed or not. Also, we put some suggestions here, where the coefficients are. You can choose values that we are suggesting, or you can write it by yourself. Also, we put some like safeguards that you cannot enter the values that is less than 0, like you see the coefficients and the areas, and also you cannot write letters or words, because all the data should be digits. Now going to the idealization using iTwin model. With the iTwin model, it becomes easier to find and highlight problematic places that need thermal isolation or other solutions to improve the overall environment of the building. We try to make it user-friendly. After highlighting, it's easier to render views, just one click, and you can save picture to your computer, and the picture can be used on the construction site by the workers. So we modified interface a little bit. So at the bottom, you can see a few buttons that help to highlight the objects. And at the top, there is a screenshot button that creates a picture of a computer screen. And now we are going to video. The video has no sound. Wait, what? according to the data, the most problematic places in the building are found and marked. View of the screen is generated using the screenshot button. The views are used by the workers on the construction site that I said before. And that's it, I guess.
The silent is good as well. And now the questions time.
Thanks a lot. I appreciate the detail. The question is rather technical because you mentioned that you can sort of model thermal bridges, but then you talk about the walls. We all know that the problem in most cases actually lies in intersection. So is there a risk that actually I get to renovate 2 walls instead of 1 intersection because I get the wrong data? Do you get my question? Because especially if I have an intersection where I have the ceilings and 2 walls, right? So I will get to renovate like half of the building instead of actually renovating the point. And the system will suggest to, demolish half of the building. Do you follow me? No?
Yeah. I honestly don't know what to answer to your question, but it could be possible to renovate more than we will be calculating.
Okay, thank you.
Any words about the competition? Or there's nothing similar on the market? Okay.
Just wait a second, I will give you a microphone.
In Lithuania, particularly, the renovation, how works renovation, that you pick a building and you renovate all of the thing. And we tried to find something similar, and to be honest, we couldn't.
Do we have questions from the remote side?
No, thanks.
Okay, thank you for your presentation. It was the team Petone. And now I would like to serve the joke that will be not very much fun, but I will do anyway. This team is not found because their number is 404. So the team number 6 and 404.
Hello everyone. So our team's name is 404 and now I'm going to present our idea. So first and foremost, we found an issue that is crucial for all students and their universities. Have you ever wanted to use a lab equipment but you weren't sure about its vacancy? So, of course, you can go to the lab and find out yourself that there is no free equipment, but we can offer you the opportunity to get that information from anywhere that you want. So, therefore, we decided to create a system that visualizes the arrangement of the assets and in the lab and the availability of lab equipment. Obviously, there is benefits for students and universities. Students get the chance to manage their time more easily, and universities can ensure work safety. Also, devices are constantly being tracked, and they also get occupancy history and user traceability. So how we thought at first that the program should work. All equipment should have sensors installed, and those sensors together with reservation system should transmit information to the digital twin. And the digital twin would process that information and would demonstrate the arrangement of the laboratory assets, and all that information would be transferred to the app. But as we are not the programmers, we tried using the iTwin platform, but it seemed way too difficult for us. So we managed to do a code with Python. We used simple functions and graphical user interface called TickInter to achieve our goal. And later I will show the video how the code works. Our final goal would be to make an app, but that app would not only show the availability of the equipment, but also it would show energy consumption of the equipment, even occupation prediction. So, but to achieve that goal, we assumed that the support of 2 IT specialists would be fundamental, and a certain amount of smart plugs with energy monitoring would be cool as well. And we would need web hosting service to make our program accessible at any time. So now I'm going to show you the video.
In this video, you are going to learn how our prototype works. First and foremost, registration to the system is needed in order to select a laboratory. After selection of a lab, the availability of lab equipment is visible for that day. If the assets are painted red with moody face, then they are occupied for the whole day. Obviously, if the assets are painted green with a cheerful face, then they have at least one available time for that specific appliance. The program gives the option to choose the time which suits the student the most. After selection of the time, safety instructions must be read and confirmation of reading comprehension is needed as well. Lastly, the program generates statistics of most used laboratories, overall electricity consumption of last 24 hours and the prediction of occupation for the next 24 hours.
Okay, thank you. From the voice of the lady, I just felt like I just watched TikTok movie. I don't know about you, but yeah, thank you.
That was the idea.
Very good idea. You attract the attention. So questions time.
I have a question on market. So, for whom is this app intended? Is this for if you're a university? Is it for university? Is it for individual user? For a student? For whom is it? Who is going to buy it?
The buyer would be universities, and the users would be students and university employees.
And why would university spend money on buying it?
To help students.
Okay. What about the maintenance of the equipment? Have you thought about maybe other uses? For example, this is just occupied, not occupied, booking the time. Do you envision more functionalities, maybe just, from the top of the head, for example, to plan the maintenance? Because a lot of people are using this equipment. You can plan that it will break. Any other ideas how you can develop this further?
I don't know, just as we said, we could do energy consumption or prediction of occupation. That's about all what we assumed.
Yeah, we still have some time. I appreciate the video, great one. The question rather technical to clarify. So I understood that this is like a real-time monitoring coupled with reservation, right? So you can see if there's anyone working using the equipment, right?
Yes.
And the prediction would be sort of based on both the real time, and then you can calculate how many basically reservations never finalized to actually using the equipment, for example, right?
Yeah, it would be mainly on data that we would pick.
Okay, thanks.
Do you have some ideas how to use it 3D model? Because here you just used 2D, maybe, you know, to take some geometry and volumes, maybe some attributes from BIM models or some scanning, let's say, outputs. What do you think?
For that, we are saying that we need 2 IT specialists because we are not the programmers, and it is hard to code even that code on Python. So. I guess so. Perhaps we could try something like that.
Okay, thank you for questions. Thank you for answers. It was the team number 6, 404. And now, round of applause. And now we are moving to the team number 7. And to be honest, I'm the most happy about this team because they changed the title from the last time. I will not mention the title, but I think that majority of you remember it. But now this team, it's called InstaTilt, if I pronounce it correctly. But you did it great. You changed the name, and I truly believe in you now. But it's still a progress.
Hi. So we changed our name to InstaTilt, and this is our team. It consists of 5 people. That's me, and the other guys that worked on this project, and we are here to present you our product. Okay. And we are the company that produces the necessary equipment and the BIM modules, and we provide it to the users. And the range of users is very broad, from construction workers, construction businesses, from person, the user, and the companies that demolish the buildings. So we made a very simple construction. We can say that it's some kind of warehouse from concrete. We made it to show you how all of our equipment work, and I want to say that the settlement of the building might occur due to very different reasons. The one on the left side shows the erosion of the soil. There are a couple of types, and that's the result. Also, we can create not just a building, we can make it on a bridge. So that's the module. We made one support, a displacement of support 1 meter. So if the soil goes down and our foundation goes also down, that's how our building might look. The colorful lines show the settlement. As to prevent that, we mount the tilt meters on each column to register the tilt. The tilt meter shows how many degrees have your construction tilted, and with our equipment we can transfer the tilt from tilt meter to a router that is connected with the internet, and it goes to the cloud and straight to the client, to the user. So it's a matter of minutes, and you can see how much has your building settled in a time of a minute. So, and that's what our users will see. You might see that on the phone or on the computer. The one column that has settled shows the red colors, and other columns also settled, so they show a yellow pattern. And the ones that hasn't settled, they don't show a color, but they show the settlement. So the maximum settlement of a foundation is around 2 centimeters. It might differ from the construction of a building. How tall is it? How wide is it? What is the soil? And we as a company provide this data to the whole app. And that's what we provide. And that's it. Thank you. Yeah.
Thank you. Questions?
Once again, the competition. Maybe you can say a couple of words, because I've seen similar solutions. And how are you better?
As a matter of fact, I haven't seen them in Lithuania. We provide 24/7 service. We don't take any charges on the whole equipment. We just take it for the installation and a monthly fee for a service. And it's very easy. You don't have to do anything. If you're a user, you will be connected to an app where you will see everything. We maintain all the difficult work because obviously the user is not that smart as we are. So so couple of things might be slipped because they don't have the knowledge as we do. We provide the simple data.
Can you say also a couple of words on the market, because I can predict that 80% of bridges in Lithuania need maintenance. So what is the market?
The market is very big. We can supply this to many stages of a building. We can supply it for the construction of building. In the whole construction, to build a regular house, it takes about 1 to 2 years. And in a whole time, you have to see how the foundation, how the house settles, because you put the weight on it. You have to see every data. When the building is done, you have to see how it performs, because the people go in. All the loads might affect the settlement and the demolishing of a building. Also, to increase the safety of demolishing a building, you have to see how columns, walls are affected of demolished upper levels. or some kind. The market is big.
Yeah, actually, the problem is quite huge. My question is, you sort of started answering to it. What about the prediction? Because post information is not that valuable, but is there a possibility to predict what will happen using the data you are collecting?
I don't think so. All the predictions are made in the stage of creating a project, the whole project of a building. There are all the predictions, and we provide the data at the moment.
Okay, thank you for presentation. Thank you for questions. And now let's move to the team number 8, and the team title is Bridge Future or Future Bridge.
Okay, so 1 month ago, we as a team of civil engineers presented an idea that we could build a prototype that could analyze bridges in order to follow their maintenance. As a solution, we selected to digitalize information on iTwin, centralize the information in one platform, and of course upload it regularly. However, we chose to create a prototype using Python, considering we have at least a little experience working on it. So here's an interface of our program. Imagine you have 2 files, one with collected data about bridge foundation, and secondary file is with updated information after 1 month. By clicking one of these buttons, you can open information about one of the foundations, and you can collect information from the older data and update it to the newer data, and you can see the difference by subtracting one from another. So by this prototype, by this program, we tried to make to prevent bridges from being closed before it is needed. So, do you have any questions?
Do we?
Just to double check, so you have the 2 versions which you compare and you look for differences, and from that you make decisions.
Yes, we see that how, for example, soil compaction has changed. We see, for example, the difference how the corrosion of metal structures changed. We can track road cracks, for example, and anything we compare older information to the newer.
And what kind of data set would you need for that? Photogrammetry or laser scan? Photogrammetry?
Yes, definitely, maybe drones.
Okay.
Yeah.
Okay. Right. Thank you.
Yeah, thanks a lot. I would like to build on it. So how do you collect the data? I mean, where do you get it from? You mentioned corrosion. How do you evaluate that?
Yes, if we work on this project further, our plan would be to manage how to find out how to collect data automatically using drones, just by scanning the bridges.
So you think drones they are that powerful? Great.
Yes, we believe we can notice the differences.
You didn't mention anything about your team and what skill set do you have in order to achieve this kind of solution?
All of us are civil engineers, and our skill sets of programming is at the very base level.
Have you tried to use the no coding systems for prototyping? They're pretty easy.
Not yet.
Okay.
Okay, thank you for your presentation. It was the team number 8, Bridge Future. And now please welcome to the stage team number 9, and their title is Statybininkai.
Hello, everybody. So we are team Statybininkai. Our members are Mantvydas Katinas, Simas Kazlauskas, and Dovydas Kirys. And we found one problem, that it's very inaccurate air pollution tracking in Kaunas city in real time. You can see some of examples. One there is where you can see only few points, and it updates only for the past, not in real time. And another one is with more points, but it updates only a few times during night and day. So our solution for this is web and app. So we achieved that you can mount some of the sensors on buses and public transportation and the stationary, and you can track your air pollution in real time. So benefits of this is improving your health to avoiding areas with a high level of air pollution, planning your activities around time of the day when air pollution is lower, tracking your personal exposure to air pollution over time. Also learning about air pollution and its health effects, finding ways to reduce your exposure to air pollution, and of course, long time data management. And I will show you now video how it works.
Kaunas City map on iTwin platform. In total, we managed to get 31 sensors that are working real time, that are measuring air pollution. For example, this one in Dainava, close to the Krivės Prospect. You can see that the sensor shows that pollution level is small. Also, it shows the dimensional values of particulate matter, nitrogen dioxide, ozone, carbon monoxide, sulfur dioxide. It also shows the sensor's battery level, which is pretty good, and the connection, which is not great. Maybe it is because of the trees are blocking connection. Might be some of that. So that is basically it.
Thank you. It was the team Statybininkai, and now questions time.
Maybe just about the visualizing. This was an example I understand. So that how would you envision this map, for users to be used and understood?
Yeah, so there is 6 graphs of exposure you can get, and you see maps with markers and points where now their tracker is, our sensor, and you can see that's location pollution. I don't know if I answer your question.
Okay, so moving points with data.
Yeah, moving points and some points which are stationary, maybe near parks or somewhere else's places where cars cannot go, and but you can still track pollution.
All right. Okay. Thanks.
Thanks for the presentation. Sorry if I missed that, but what is the value it creates to the user?
Better health.
How?
Because you can.
Because I don't go there, or what?
Yeah, no, but you don't know in real time what air pollution is. You don't know how much carbon monoxide or something else is in the air, and you can track that. So maybe if it's hours after work where everybody is going home and there are cars a lot, so maybe you can just check that app or website, and you can see if you can get a.
So would it be used by a person like me, or would it be more useful for a municipality, for example?
Yeah, I think for everybody, it would be great for your personal use and for, like I said, long-term data management.
Okay, thank you.
So maybe to add a bit on top on what was just asked, just getting the data is one thing, but just giving something to offer to clients would be very beneficial. For example, signaling that you are in the location that is at the moment signaled as a very polluted, because I can assume that if you would place your equipment next to Žolynas, it should be clean there, right?
Yes.
But it shouldn't be in some Savanorių prospectus or something like that.
Yeah.
So at this point, maybe extra features, for example, just signaling the users that it's highly, I don't know, contaminated.
Yeah, it's a kind of great event.
That would help.
Thank you. And now we are moving to the team number 12, Varškėtukai. The favorite one.
Amazing. Hi. Can we, please? Amazing. Okay. Hi, my name is Idanis. I am from team Varškėtukai, and I will present to you our indoor navigation app, BAPS. If you recall my last presentation, which some of you don't, I talked about getting lost inside the hospital. we can all imagine how unpleasant, how uncomfortable it feels. And it turns out we are not the only ones. We made a survey, and the majority of people agree with us. They find places like hospitals, shopping malls, airports difficult to navigate in, just complicated and unnecessarily unpleasant. Our solution is simple. It's basically a 2D and 3D business property map, which gives you step-by-step directions to wherever you need to be as a business client. What's special about us is that we offer customized services. For example, search by flight number in an airport, by visit ID in a hospital, promotions to selected sub-owners in a shopping mall, and so on. Additionally, we make both the app and the planned routes accessible to people with disabilities. What we have done so far is create a prototype, an app that allows you to navigate the KTU MLab facility by searching for a room, then shows you the path that you should take. You can switch between 3D view and 2D view. You can switch between different floors, and you can, of course, see the directions at the bottom of the screen. Once you complete a certain step, you can click next, and so all the way to your destination. In the future, one of the main upgrades will be detecting the user location via the use of Wi-Fi stations or Bluetooth tags. Our broader business roadmap looks like this. First, a demo launch with just a couple buildings, maybe shopping malls or other public institutions. Then we can expand locally and we can analyze our performance, our clients, the needs and wants of the market. Finally, we can launch internationally, gain support, get partners, and expand into all directions. Our presentation was quite simple, quite short, because I want to hear what you think we missed in it, what is important to you, and what you would like to hear.
Okay, so let's begin. So what did you achieve during the month?
So we using the Unity engine, we created an app where you can pick a room and it shows you the path to that room.
Amazing. And I really loved that you actually touched upon the accessibility topic. It's actually a very huge problem, but only the people that are disabled, they feel it, because it seems to us it's all clear. No, it's not clear. And these people, they usually stay at home because of the reason, because it's difficult to get to somewhere. So it's a very good angle, and you can skip everything else, just stay with the accessibility. That would be powerful.
Thank you.
Okay, just a quick comment. I agree with those 111 people who said that it's really hard to navigate sometimes. So thank you.
Thank you.
Just a quick one. Do you have a video or something to show us, or just that image that you had?
We have the image.
All right.
We feel like it provides all the information on one screen.
Okay, thanks. I saw your margin of error is like 0.1 meter because you had to turn left in 0.4 meter. Do you expect that you will have 10 centimeter error?
Probably not. That is for visual purposes.
All right, thanks.
Yeah, thanks a lot. My question is, did I get it right that you would need some special equipment installed in the building that the system would work? If I go to a random, it would not like locate me with the precision which is needed.
Not necessarily. Well, the first stage of the app is not having any user location at all, just a simple click next once you have completed the step. But then we can locate the user using already existing Wi-Fi stations, because we all know that institutions like some hospitals, the university, definitely all universities have Wi-Fi access points. And once you're connected, you can know which access point you are connected to. You can roughly determine how far away from it you are, and so you can determine the user's location with some sort of accuracy. But if you want greater accuracy, then you need to install Bluetooth tags on the walls and locate the user via them.
And from the business perspective, then what you offer is basically a digital map of the building. If I own the building, a hospital, you would do that and then basically upload it to the app, right? That the users could have access to it.
Yes.
And can you estimate the costs? Okay, you will answer that depends on the size of the building, but let's take MLab since we talk about it all the evening. So what would be the cost approximately to do that?
To create for an
yeah, for me,
map,
I own the MLab and I ask you to do the map and install the system that the students can find the labs very easily because they actually booked it using the registration system. So what would be the cost approximately?
I can only estimate using working hours because it's mostly the working hours that makes up the cost. It's I think from 1 to 10,000.
Okay,
thank you.
We are almost at the final presentation of today's speeches, and now I would like to present the team number 15. Just take in mind that we are missing twin 14, so that would be twin 15. And the title of this team is Second.
Yeah, so I think we can start. So first of all, good evening. As you can see, our team had that distribution of preferences. So me personally and my colleague Simonas decided to work with PyCharm, while the rest of the team members chose to try iTwin. So just a quick reminder of our idea, what we presented the last time. So basically, in certain areas such as exhibitions or museums, based on the data from a CO2 sensors, we could actually solve some problematic issues, such as placement of security staff. Okay, let's go. So on the slide, you can actually see the main interface of our program. So first of all, what we had to do is, of course, to choose the main object as our main model. So we choose and decided to go with Museum Louvre. So the structure of the interface consists of three main parts. So first of all, we have just the image of the particular object. Also, we have the buttons with names of certain areas. And we have just a short label with some information provided. So basically how the program itself works, when you press the button of a certain area, you get the information about the occupancy rating in that particular zone, which is based on a data from a CO2 sensors. So, okay. Yeah, how it's beneficial. So first of all, for the awareness, I'm talking from the perspective of the managing staff, for example, seeing the increased readings in certain areas, you could actually enlarge the number of security. And from the visitor's perspective, it's actually very unpleasant and uncomfortable when you're visiting and some places are just overcrowded. So basically, by using this app, this program, you could actually track everything and manage your just visiting route. So more from a technical side, my colleague Simonas will present you.
Okay, thank you, Claudas. I'm having a bit of a problem. Does it show? Nope. Yeah. Oh, perfect. So now, yeah. Okay, onto the program itself. When you click any of these buttons, the mini window pops up, and basically the information is, well, as you can see, the occupancy is for example, like 60, 40, etc. Now, when the occupancy reaches 50 people and above, the label turns red, signaling that the area is overcrowded. Now, you might ask yourself, well, how does the program actually calculate the people? Well, the program is basically built on this simple equation that you see on the top, and it is basically the Y value calculates the total people in that specific area, while the X value is actually the amount of the CO2 gases in the area, and the X value is basically the CO2 sensor, sorry, transmit the real-time data to the X value, and the program actually updates itself, indicating the occupancy. So also this program, as Claudius mentioned before, was created for the Louvre Museum, but you can actually use it in pretty much any indoor place, any indoor commonly visited place, even in your house maybe. Just put a CO2 sensor, write this code, and you should be able to monitor that place with no problem. And another thing also, if the X value exceeds enormously, that basically means that the fire has broken out in that specific place. So it could also be as a backup fire alarm. So thank you.
Questions? Željko, maybe you have? No, Željko, I believe he's
sorry, I was
one.
muted. How often are sensors refreshing the data?
Well, it's depending on the preference. It could be on the minutes. Right now, the program generates numbers randomly since we don't have the actual CO2 sensor. But it could be, 15 minutes, 5 minutes, 1 minute, however you like it.
All right. Okay, thank you.
A typical reason we measure CO2 is to decide about the effectiveness of ventilation. So if you have a really smart ventilation system, adjusting the airflow according to CO2 sensors, you will see CO2 level at the same level, even if there are more people or less people inside. So can you tell us a bit, have you analyzed these kind of systems and how it will interact with your solution?
Well, to be honest, I didn't analyze it very deeply since the algorithm itself for CO2 calculating for this equation is really, really difficult. It basically evaluates the volume of the specific room, as you said, ventilation and many different factors. So no, yeah, it needs.
I would add just very brief comment. If the ventilation is poor and CO2 level is high, you can recalculate it to the risk of cross-infection, for example, with COVID or flu. So you can visualize the risk of infection by the number of CO2. Just a suggestion for you.
Okay, perfect.
Or maybe measure CO2 levels in the extract air. So maybe also a solution.
Thank you.
Okay, so I think that's all. Thank you.
Thank you.
So that's all. 11 team pitched their ideas, and I would like to ask you to give yourself the round of applause because you made it. It's the finish. And now we, as participants, we will have 15 minutes break, but jury will not have this break, definitely. They are going to work and they are going to decide to the breakout room who will become the winners of this hackathon. And information for you, those who did not register themselves, please do that, because if you did not sign, you will not be able to receive the certificate. So please, the sheets are on the desk. Vienas, vienas, vienas. Okay, I think that we can start by now. So welcome back, everybody. I hope participants have rested a little bit while our jury were intensively discussing all the team's pitches. And now I would like to ask the jury members, including the Vice Rector for Research and Innovation of KTU, Leonas Balaševičius, join our stage and be vice versa. You know, you were standing in the audience. Now they will be standing in front of you. And I will start from the new members. So Leonas, please, maybe you were the observer, you were the listener, and you were listening all the pitches. So maybe you can provide the insight from your side.
First of all, good evening to all. So I'm very excited to see such a big audience and a lot of teams who presented their ideas. I just observed from my side what I could tell. Maybe you feel that theory and practice a little bit different and there are challenges when you implementing theory knowledge. First of all, you saw that when you get in the team, so you need to share responsibilities. You need a leader. And even if you have a bad idea, how it's important to sell bad idea and to prove the investors that we need to invest in your idea. And for the customers, that customers are going to use that product or app and what will be benefit for that. So I wish you not to stop at this stage. Even if you switching to other activities, just continue with that the same team, maybe to attract to the team other students from other faculties, or even to change your field a little bit by taking the Bachelor Plus or Master Plus studies. So good luck in your future.
And now the team members, thank you, Leonas. And jury members, this is the challenge for you. Please give us a pitch about pitching. One sentence for wrap-upping what happened before.
It's gonna be a long sentence. So once again, I'm Andrius Milnevičius. I come from Baltic Sandbox Ventures. It's a fund that will be investing in very similar solutions that you are building here. So if it seemed that my questions are a bit challenging, but that's exactly why do we participate in hackathons, right? We need to challenge the ideas and you shouldn't be taking it personally. It's just like when you participate in a hackathon, so please do ask the mentors to challenge you, because then it's much easier for you to defend the idea while standing here on the stage. At this point, I saw some teams that you were focusing on the idea, right? We want to do this and that, this and that. For the sake of the hackathon, ideas are cheap, they're not important. You have to find very big problems. You need to understand that funds or investors, they do invest in problem solution fit. They really need to see how big is the problem, whom it actually hurts, and if you then present the problem, if you show that there is a very big audience, if there is a market, then no one will be asking some small details about the solution that are not that important at this point. So once again, I would like you all to clap for yourself, because you had so many various ideas on how to spend the weekend, what to do today, tonight, right? But you're still here, it means you care about it. And maybe the last bits from my side, having a bit bigger ambition that you showed today would be very beneficial for all of you. But at this point, we are learning, right? Hackathons is a perfect place to learn, so wish you all luck. And if you feel that those ideas that you investigated during the month, you feel that they are important, please do proceed with them, because you can create a very interesting life for yourselves.
Yeah, you were right. That was a long sentence. But thank you for that. It was really inspiring wrap up. But I think that we have several members who want to provide us insight as well. One sentence. Also very long?
Žalia balta, žalia balta.
Hey, hey.
It was just a warm up. Actually, I think we learned today that you cannot do everything alone. So actually, it's one for all and all for one, because you need team members, and you have to look not also among your friends, but also farther away. So this is my wish to you, all of you, actually, to find the right team members and continue the journey. Thanks.
I like the part of Žalia balta. Thank you. And now, yeah, of course. One sentence.
Okay, everyone is talking about the future. So the future is very bright for you, because all you have in the next semester, you have a new course, a product development course, where you also can proceed with your ideas. So just please do.
Very good practical advice for you. And now we are moving to the award ceremony, and the dean will announce the winners.
All right. You did a good drum roll last time, and I was reading last time. This time, I believe I remember the names of the teams. If okay, just in case. Okay, we will start from the third place. So we decided to split the prize fund. The team number 1 will receive 1,500 euros. The second team will receive 700, and the third 300. And we believe that really these three teams demonstrated something really tangible, really something that can be applied. And yeah, these were really good solutions. So we'll start from place number 3. I invite all the team, when I will announce them, of course, go down, shake hands with the jury, or don't if you believe that you should have been higher. I don't know. So yeah, drum roll. Team number 3 is Instatilt. And then let's do a picture. In the center for the picture. Team number 2. Again, let's do the drum roll. Varškėtukai. This is like a basketball match indeed. No, no, no. And finally, yeah. The team number 1 is Life is Easy or Hard. Thank you very much. Thank you for the jury, for all the teams. Watch, follow our streams. We will be doing the hackathon next year. As I mentioned, you are welcome to participate. You know very well that both students, alumni, or just, anyone can join the hackathon. So you can, if you like this, if you want to continue working on this, or maybe develop the next idea, you can even think of it now. All right, family photo. Yeah, Željko, would you like to say something?
Željko, are you here
No,
with
I
us?
just want to congratulate everyone. You guys did really a great job, and as other speakers said, please take this idea, take this half-baked solution, and make it a real solution. But what makes all the difference in a life is executing whatever you think of. So thank you all, and hopefully we will see you next year again.
Thank you.
Okay, so the idea is to do a joint photo if you're still here, or the jury will take the photo.